Hmm. Welcome back. Now I'm passing to the next chapter. It's comparatively very simple chapter. It is development of surfaces. Okay. So I'll illustrate you the concept of development of surfaces with some physical examples. This is a triangular box. I'm wrapping this box with a sheet of paper. Okay. Wrapping this box with a sheet of paper. Now I'm spreading and unfolding this sheet of paper and spread it on a surface. Okay. So I'm spreading it on a surface like this. I'm doing this same thing in another way. So I'm opening this box from cutting it one corner cutting the box from one corner. Now I'm unfolding it. Okay. So I got a shape, rectangular in shape like I got. And this process is called as the development of surfaces, and the shape that I got is called as developed surface. So this is a developed surface, and the whole process is called as development of surface. Take another example. We consider a cylinder. Okay. I'm wrapping this cylinder with a sheet of paper. Then I open it, spread it on a surface, and this surface is called as the developed surface of a cylinder, and the process is called as the development of surfaces. And what is actually I got is the hollow cylinder. Okay. I open it. I got the development of a cylinder. And the main application of development of surfaces is in sheet metal industry. So how will you apply this development of surface concept in sheet metal industry? Suppose if I want to make a cylinder of this dimension, this sheet will give an idea regarding how much quantity of sheet is required, or sheet metal is required to make this cylinder this particular dimension. Okay, so I cut the shape, then I fold it, join at the end, I got a cylinder. But remember that what we are making is a hollow cylinder. The development is usually applied on hollow solids. And what is this represents? This surface represents an area, the area of sheet required for making a cylinder of this particular dimension. Okay. Now, what is this length? This length is equal to the perimeter of the solid. For the case of a cylinder, this will be equal to 2 pi r, where r is the radius of the circle. So this surface or this length represents the perimeter of the circle. What is this length? This length is equal to the height of the solid. For example, in the case of a prism, This length will be equal to the perimeter of the solid. Since this is a rectangular prism, length plus breadth, so L plus B and into 2. 2 in L plus B is the total length of the sheet required, and this length is equal to the height of the solid, height of this box. If I want to make a rectangular box of this particular dimension, what I have to do is first of all find out the area of the sheet required, then you fold it, divide this into 4 equal parts, fold it along the lines, then you can have a square prism or rectangular prism. If it's a square prism, divide this sheet in area length into 4 equal parts, fold it 4 times to get the solid. If it's a hexagon, fold it 6 times, you get the hexagon. Okay. So this is and you can see that here the unfolding of the sheet is taking place parallel to the axis of the solid. So this development is called as parallel line development. The cylinder also, you are developing the solid parallel to the axis, so it is called as a parallel line development. Okay. So how will you draw the development of a solid? And you have to remember that this surface represents area, or this shape represents an area of a solid, okay, and it's a 2D drawing or 2D plane. So you can see that the development will always represent a 2D plane drawing. Okay, and all measurements are true measurements. See, this perimeter is a true measurement. The height is equal to the actual height of the solid. So all dimensions are true dimensions in developmental surfaces, and you can see that never draw dotted lines in developmental surfaces, because all the edges are boundary edges, so you will never draw dotted lines. Okay, how will you draw the development of a square prism? First of all, draw the square, plan and elevation of the square, then draw a line, horizontal line, such that its length is equal to the perimeter of the solid. So its length is equal to perimeter. In this case, example, here it will be 4 times the length of the square. This is length. The side measurement is L. This is 4 times the length. And this height is equal to height of the solid. So draw a vertical line such that height is equal to the height of the solid. So I can draw a horizontal line to the top as well as bottom. Then, since this is a square, divide this 4L into 4 equal parts. So each segment will represent L. Okay. Suppose if it is a rectangular prism, L plus B, the first segment will represent L, then B, then L, then B. So the total length will be equal to the perimeter of the solid. Okay. Now I am marking A, B, C, D. So I am marking here A, and A to B distance is L. So A to B distance is L. So this point is B. This is C, B, C, then D. What is this point? A, starting from A, B, C, D, and again A. So this is very important. In developmental surfaces, the starting point and the end point remains the same. How it happens? Because you are cutting this object from one corner. Say this point is A. So I am opening it from here. So this is A, B, C, D, again A. If I am marking here P, this will be Q, R, S. With this point, this should be P. Starting and end point should be the same. Okay. Now we take the case of a cylinder. Plan derivation of a cylinder. You can see that this is a plan derivation. Okay. What is its length? this length will be equal to 2 pi r, where r is the radius of the circle. Okay, and if you are dividing the circle into 4 equal parts, you can divide this also into 4 equal parts. So this is A, B, C, D, okay? A, B, C, D, and E. If you are dividing the circle into 8 equal parts, divide this portion also into 8 equal parts. So A, B, C, D, E, F, G, H, and this will be again. If this is very English, we will be drawing the development of a cylinder. And what I have discussed here is parallel line development. So you should remember, developed surface is always a 2D surface. Okay? And all measurements are true measurements. Never use dotted lines in development of surfaces.